All right, time to review Unit 2, and so we can be all ready for the test coming up here. So first thing we need to do is we've been talking about these parallelograms, rectangles, and rhombuses. So we're going to put them all together, and we want to make sure we know what the main properties are of these things. So first, a parallelogram. We got 5 things we know about a parallelogram. We know that opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Remember, consecutive angles are ones that are right next to each other. So this angle here and this angle here in the green parallelogram. And finally, the diagonals bisect each other. So those are the 5 things that we need to be familiar with in a parallelogram. Then we have special things about a rectangle. The 2 special things are all angles are 90 degrees. Then we know something about the diagonals. And then that is that the diagonals are congruent. So that's a rectangle. 2 things about a rectangle that are special. A rhombus, we've got a couple things here. First thing is that all sides are congruent. So all 4 of these sides are exactly the same. That's the definition. And then we know that diagonals are perpendicular. They intersect at 90 degrees there. And then the diagonals also bisect the angles here. They cut these angles in half. So there's our 2 things about a rhombus. 3 things about a rhombus. 2 special things for a rectangle, 3 special things for a rhombus. Okay, well, let's talk about interior and exterior angles in a polygon. So remember the interior angles. We have our formula n minus 2 times 180. N is the number of sides. Okay, so our total interior degrees is n minus 2 times 180. That's for the interior angles. We should say interior. Remember, that means the inside. So then n, because it's a decagon, is 10 minus 2 times 180. All right? So we have 8 times 180. And that gives us 1400 degrees. Now we want one interior angle. So we can say take 1440 and divide it by 10. And that gives us 144 degrees. That's one angle. Okay, so that's the interior angle. The next question is an exterior angle. Well, if we think about a decagon, decagon has 10 sides. It's going to be tough to draw exactly. But if we just think about part of it, if we take all of the exterior angles here, remember they all add up to 360. So the total exterior is 360. And so if they all add up to 360, we have one angle is going to be 360 divided by 10 because it's a decagon. Decagon has 10 sides. And so this is 36 degrees. Okay. Also, we just found out that the interior was 144 degrees. So these two have to add up to 180. And so if you ask yourself, what do you add to 144 to get 180? Well, that's going to be 36 degrees. Okay. 2 ways to do that. All right. All right. So let's keep rolling here. We got a parallelogram, number 4. So if we got a parallelogram and we got these 2 sides, now hey, on a problem like this where we're given some information about the sides, this side is 6x minus 4. This side is 56. It's a good idea to label it right on that drawing, okay? And so now we're looking at it and we're saying, well, those are opposite sides. What do we know about opposite sides of a parallelogram? Well, opposite sides are congruent. So these 2 things have to be congruent. So the 56 and the 6x minus 4 have to be congruent. These are not angles. They have nothing to do with 180s or 360s. These are lengths of sides, okay? So lengths of sides is how many inches they are, something like that, all right? So now we can solve this. We can add 4 to both sides. 60 equals 6x. Divide by 6 and we get x equals 10. All right? Pretty straightforward there, hopefully. Now we've got a pentagon. Now we're talking angles. Now we're talking degrees. Okay? And so we've got a bunch of angles. First thing we need to do is we need to find the total interior. And so our total interior, we're going to use our n minus 2 times 180. N is the number of sides. In this case, it's 5. So 5 minus 2 gives us 3 times 180. That's 540 degrees. So we know these guys have to add up to 540 degrees. So we know the grand total of all these angles is 540. Just write it out. They'll add up to 540. Let's combine like terms. These guys right here, whoops. These guys right here are going to add to, we got 252 and 225 and 80, it's 336. So 3x equals, nope, sorry. 3x plus 336 equals 540. Let's subtract 336. And that should give us 204. And that's 3x. And if we divide that by 3, should be divisible by 3. And that gives us 68. Let's make sure we answer the question. The question just says solve for the value of x. There it is. All right. Oh, you know what? Coming back here on number 4, looks like we missed a couple parts. I thought these were separate problems. Let's look back at it. We can do that. So the question is, are D and C congruent or supplementary? Well, these are consecutive angles, not opposite angles. So these are supplementary, and that is because they are they're consecutive. They're supplementary. Okay. And that's because they're consecutive. So what about, so C and D here, if we give you some expressions for those, okay, now not a bad idea to write these in. We've got 2y plus 3. That's for D, 2y plus 3 degrees. And then we have 3y plus 17 degrees. All right? And so we know those two things add up to 180. We can see they're right next to each other. Look at them, by the way. Don't just ignore the fact of what that looks like. You can tell these guys, they're not the same. We've got an acute angle. We've got an obtuse angle. All right? So these guys add up to 180. We've got 2y plus 3 plus 3y plus 17 equals 180. They're supplementary, which means they add up to 180. Okay, let's combine like terms. Don't try subtracting from both sides yet. Combine those like terms. We've got 5y. 3 plus the 17 is 20. Now let's subtract. And we've got 5y equals 160. And let's divide by 5. And we get 32. Okay? So that's the idea there. All right? So let's move on and check out some more. All right, page 2 here. Got some more parallelograms. The question is, what is this angle here? Well, if angle D is 43, well, we can go a couple ways about this here. We know opposite angles are congruent there. All right, so that's got to be 43. Okay. And we know this whole angle here, this angle is supplementary to 43. So why don't we take 180 minus 43, and that's going to give us 137 degrees. So this whole angle's got to be 137 degrees. Now, if we take that 95 away, we'll be left with our question mark. 137 minus 95. Well, 137 minus 100 would be 37. Let's put that 5 back in there. So we got 37 and 5 is 43. Okay, so 43 degrees. Wait a minute. That would be 42 degrees. There we go. All right. All right. Found our missing angle. Okay. Here's a question. What if we got YVWX as a parallelogram? Diagonals intersect at M. And we got some description here. We know WM is 32. Well, this one's a little more challenging because we don't have a drawing. Well, that's easy to fix. Go ahead and make a drawing. That's a great idea. Whenever you don't have a drawing, make a drawing that's being described. We've got a parallelogram. So let's draw a parallelogram. YVWX. Okay, the diagonals intersect. Okay, and at point M. And we need to know that this is the midpoint. So if WM is 32, that means this guy over here has got to be 32 also. And so the length of the diagonal has to be twice as long. So YW equals 2 times 32, which is 64. Okay? So the length of that diagonal is 64, double that given length. All right, how about a rhombus here? Well, a rhombus, we know opposite sides are congruent. Okay, and we're told some angles. BDC is 42. So BDC goes from B to D to C. That's this angle right here. So this angle is 42 degrees. Let's label that. Again, real important to write these labels on there. DE is 8. That's the length from D to E. EC is 6. Well, we know some things. We know the diagonals bisect each other, so those both have to be 6. That has to be 8. What else do we know about the diagonals? Well, we know that they're perpendicular in a rhombus. Okay? The diagonals are perpendicular. And then one more thing we found out is that the angles, the diagonals bisect the angles. So that has to be 42 degrees. And these two are going to be 42 degrees over here also. Now, what's the question? It says, well, find and label the missing angles and segment lengths, okay? So these are all 90, 90, 90, 90. And so look at this triangle. Here we have a triangle. We've got 42, 90, and something that I don't know. So we know x plus 42 plus 90 has to be 180 degrees because the angles in a triangle add up to 180. All right, so that's 132. Subtract 132. And we get 48 degrees. Okay, so we got 48 degrees there. So these are all 48 degrees, 48, 48, okay. Last thing we don't know is we've got to find this length right here. Okay, actually I might call that little c because you see the right triangle here. Okay, if we want to know this side, we have a right triangle. How do we find the missing side of a right triangle? We use our Pythagorean theorem. 6 squared plus 8 squared equals c squared. And that's 36 and 64. Keep working your equation down the page. And then in the end, we're going to square roots. Okay? And we come out with a nice whole number, 10. Doesn't have to be a whole number. In fact, usually it won't be. Okay? So this is 10. So all the sides are 10 because it's a rhombus. All the sides are the same. So a lot going on there, but the idea is by just giving a few pieces of information, And knowing that it's a rhombus, we know that the diagonals are perpendicular. Diagonals bisect each other. And then the diagonals bisect the angle. So if this is 42, this has got to be 42. And because opposite sides are congruent, these are going to be also 42. The opposite angles are congruent, that is. All right? One last thing here. So let's say we make a quadrilateral. We've got some quadrilateral. We know that two sides are 12. Two opposite sides, that is. 12 and 12. And then we're going to connect the other two sides are going to be 30 inches. So the question is, does that guarantee that it is a rectangle? Well, we could check to see that if it's a rectangle by measuring the diagonals. If those diagonals are the same, then it is a rectangle. Okay? If it's not, then we need to make it the same and to see if it really is a rectangle, all right? We could bend it over kind of idea. So we could say, we can measure the diagonals. If all we're going to do is we're just going to measure with a ruler, we don't have a protractor, we just have a ruler, so we need to measure the diagonals to see if that's a rectangle. So we want to measure the diagonals to see if they are congruent, okay? And that will tell us if it's a rectangle. All right. So there you have it. Special stuff about rectangles and parallelograms and all kinds of fun stuff there. All right. So make sure you got those properties memorized and that you're ready to apply them.